Hi guys, we're back with more Alkane, believe it or not. We are in a general chemistry course, but this is an organic chemistry section. So a lot of general chemistry courses or second semester of general chemistry, they kind of end the whole thing with a little bit on organic chemistry. That's what section 20 is all about. So if this is for you, this is video number 2 from section 20. And this video is very kind of target specific. This video is about 11 minutes of how to name alkanes. And then once we learn the 4 rules, right? Once we learn the systematic rules on how to name alkanes, we're going to practice, okay? I'm going to give you the structure. We write the name. If I give you the name, we have to come up with the structure. So we'll do it both ways. Okay, so let's get started. Top of page notes. This is section 20, video number 2. Nomenclature of alkanes. Nomenclature is just a fancy word for naming. Okay, so we're going to learn how to name alkanes. There's 4 rules. So we're going to take a lot of notes at first on the 4 rules, and then we're going to kind of have less notes and more practice. So number 1 is the first rule on how to name alkanes. The name of the unbranched alkane, remember that's just a straight chain, links with no branches. The name of the unbranched alkane is obtained by adding ane, that's a suffix, adding the ending ane to the root name for the number of carbon atoms. Pentane, hexane, etc. Okay? Now for a branched alkane, the longest continuous chain determines the root name for the alkane. The longest continuous chain will be kind of like the parent chain. Rule number 2. All this will make much more sense when we put it into practice. I'm just getting the rules down in our notes. Number 2, when alkane groups appear as branches off of the main or the longest parent chain, they're named by dropping the ane and replacing with yl suffix. Here are some common alkyl branches. You see this one almost in every single molecule. CH3, methyl. That's called a methyl group or a methyl branch. CH2CH3, that's an ethyl branch. CH2CH2CH3 is a propyl branch. Notice the YL endings. If I have 4 carbons acting as a branch, that's called a butyl group or a butyl branch. Now, another way to have 3 carbons be a branch is branching at the middle carbon, that's isopropyl. Another way to branch 4 carbons is on the second carbon in. This will be sec-butyl, okay? And on the third column over here, if we have the following branch, CH2, then connected to a carbon with 2 other carbons on it, that's called isobutyl. It's an isobutyl branch. And the very last branch I'm drawing down there, you see quite a bit, actually, it's a tert-butyl group. Sometimes it's not just tert-butyl, but T-butyl, T-butyl group. Okay, so those are good to have kind of in your repertoire. You want to be able to recognize the branches, but by far the most common are isopropyl, methyl, and ethyl. Those are the 3 very common. Rule number 3, positions of branches. Now, by the way, branches are also called substituents, and positions of branches are specified by numbering the longest carbon chain. This is our parent chain, right? So we number that chain, starting, because you can number a chain from either way. You could number it 1 over here at the very end or 1 over here at the very end. So which way do we start? It doesn't always have to go left to right, of course. So the longest carbon chain, you want to start numbering that chain at the end closest to the branching. Hyphens are used between the branch number that you make and the branch name that you come up with. And again, once we put this into practice, these rules will start to make intuitive sense. Rule number 4, it's our last rule, and then we're going to practice, I promise. It says the location and name of each branch or each substituent is followed by the root or parent name. That is the name of the longest continuous chain. Right, and the last part of rule number 4 here says branches are listed in alphabetical order. So branches are listed in alphabetical order, and the prefixes that we use are di, tri, 4 is tetra. Those are used to indicate how many of those particular branches we have. So those are used to indicate multiple identical substituents or branches. All right, so what on earth was all that crap I just wrote? Okay, that doesn't make any sense when you write it down, does it? I agree. We have to do plenty of examples. So here is our first example. Draw the 5 structural isomers for C6H14. What they're asking there is just come up with 5 different ways to make C6H14 and have them not be identical. So draw the 5 structural isomers for C6H14, and then let's name it. Okay, well the first one I'm going to do is just boom, 6 in a row. Okay, 1, 2, 3, 4, 5, 6 carbons all linked in a row. Put the H's everywhere. If it's all single bonds, you will come up with 14 hydrogens. Another way to write it is a condensed structure. These are both the same thing. These are this is N-hexane. Okay, I just call it normal. I'm not sure if it means normal, but I believe it does. Just normal or regular hexane. Now look, it's no longer a hexane. It's still going to be C6H14, but one of the carbons is a branch. So this is going to be a pentane, even though it's 6 total carbons, because I've got 1 carbon that's now a branch. So it's branched off of where? Second carbon in from the left. Should make sense that I'm going to start numbering my carbons from the left. If I number my carbons from the left, then that branch, that methyl branch, that CH3 branch is off of carbon 2. This is 2-methylpentane. Now I'm going to make a 5-carbon chain again, but I'm going to move the branch that's pacing up from carbon 2 to the very, very middle, which is carbon 3. This is 3-methylpentane. Okay, now ideally I could have numbered this one from either side. You end up with the branching being on carbon 3 no matter which way you go. But in 2-methylpentane at the top of the page, the far left carbon in the main chain is my carbon 1, far right carbon is carbon 6. Okay, now look at the third one on this page. It's only a 4-carbon, this is going to be a butane. It's some sort of butane. 2 different branches, both of those branches are the CH3s. So this is 2, 3, because my branches, my 2 methyl groups are on carbons 2 and 3. 2, 3 dash, not just methyl, but because there's 2, dimethylbutane. You notice how it's pentane, pentane, butane, but the formula for all of those is C6H14. Here is another butane, but I've got both of my branches. Both of my branches that stick up and down are off of we should start numbering from the far left, and that becomes carbon 2, both branches, both methyl substituents, both methyl branches, those are CH3 groups. Those are popping off of the second carbon in from the left, 2, 2 dash dimethylbutane. All right, those are my, how many did we draw? 5. Those are my 5 constitutional isomers, or my 5 structural isomers of C6H14. Right? The formula C6H14, you count everybody, not just the carbons in the main chain, but the carbons in the branches as well. Another example. Determine the structure for the following hydrocarbons. All right, they're asking for the structure, which means they're probably giving us the name. Anytime you see a big, long, crazy name like this, and I'm putting a box around right now, I focus right in on the very end, because that tells me the parent. This is nonane. Nonane is 9. Look, I'm drawing 9 carbons. I'm in charge here, so I'm going to number it from the left. Okay, because I read books left to right, number from left to right. Put a 3,5-dimethyl, and then put the ethyl group on carbon 4. Okay, so I'm redrawing that now on the right-hand side of the page. And then I have to fill in all my hydrogens. I can't just leave it bare bones, nothing but carbons, right? I have to put my hydrogens in. Okay, a lot of students leave that off on quizzes and tests, and I mark them off because it's not a complete compound. Carbon has an octet, like 4 bonds to it when it's saturated. So the 2 molecules I'm drawing on the right to the right of that double-lined arrow, these are both correct compounds. The second one is a condensed structure. All right, now here's B, another example. 4-tert-butyl. Tert-butyl, you remember that? That is a crazy looking branch. 4-tert-butyl heptane. First things first, let's draw the heptane. That's just 7 carbons in a chain. Ding, 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 ding. 1 on the left, carbon 7 on the far right. Find your carbon 4 and put a tert-butyl group up there. That tert-butyl group is a carbon with 3 other carbons spoked out of it. Okay? Now, as I rewrite it, I started too high on the page, so I just put the T-butyl group, the tert-butyl group, down below. That's fine. At first I drew it above, now I'm drawing it below. It's okay, the molecule can turn, can't it? So, the first compound at the top right, you see up there, that's correct. If I condense it all down, CH3, CH2, CH2, CH, with the tert-butyl group below it, look at the tert-butyl group abbreviation. C parentheses CH33. You see that a lot, okay? All right, so that's all straight chain alkanes. We are going to practice more naming, but we can do so in the while introducing something else, and that is not just straight chain alkanes, which we've covered in videos 1 and 2 of section 20, but video number 3, the next video, we're going to talk about cyclic alkanes. Cyclic alkanes are more commonly referred to as cycloalkanes, all one word. That's coming up next. All right, so see you for that.